Welcome, brilliant students of the universe, to today's explainer. Go ahead and take your seats, settle in, and look up, because today, I am taking over. That's right, I'm the sun, your closest star, and I am so thrilled to have you here in my cosmic classroom. You know, for billions of years, I've just been watching you learn, grow, and explore from my vantage point right at the center of the action. But today I'm pulling back the curtain on my own life story. We're going to explore exactly how I work, how I was born, and, well, where we're all eventually headed.
Okay, let's dive into this. Welcome to my cosmic classroom. I am your star, your ultimate cosmic teacher. Think of me as the headmaster of this entire solar system. And I gotta admit, keeping this whole operation bound together with my massive gravitational pull for over 4.5 billion years, it is exhausting work. It's a full-time gig being the center of attention, the sole source of all your power, and the gravitational anchor keeping 8 restless planets from just wandering off into the dark void of space. But hey, despite the fatigue of billions of years of service, I do it out of love, especially for my absolute favorite pupil. Now, I probably shouldn't play favorites, but let's be honest here. Earth, you are my prized student. I happily provide all the essential snacks and daily energy you need to thrive. I beam down your daily dose of vitamin D, which is absolutely crucial for ensuring your human bones and joints grow strong. I also perfectly formulate my sunlight so your plants can perform photosynthesis, literally creating the very fruits and oxygen you need to survive. Every single bit of biological and botanical life you enjoy, it exists because I am here, continuously providing the fundamental source of all life and energy. So, to really understand how I tick, let's review my cosmic schedule, which, fun fact, spans 10 billion years. And this brilliantly illustrates the whole journey. 4.6 billion years ago, I didn't even exist. I was just a messy, swirling nursery called the solar nebula. It took me about 50 million years of hard work and intense pressure to mature from a young protostar into the bright, steady star you see shining today. Right now, I'm sitting comfortably mid-career, burning brightly in my absolute prime. But take note of that last bullet point. 6.6 billion years from now, my shift will end, and I'll face my inevitable retirement. But hey, before we get to the end of the day, let's go back to the very beginning. Before I was your teacher, well, before the planets were even formed, there was the solar nebula. I want you to imagine a massive, highly pressurized, completely magnificent, glowing cloud of gas and cosmic dust, just illuminated with these dazzling colors. This was the nursery for our entire solar system. But it wasn't exactly a peaceful place. Immense gravitational forces began pulling and squeezing this nebula. The pressure was absolutely staggering, forcing all that swirling gas and dust to violently collapse inward. And this incredible cosmic pressure, that was the very catalyst that forced my creation. To understand exactly how I formed from that chaotic cloud, think of a simple appliance sitting right in your own kitchen. A grinder. When you put ingredients into a grinder and spin it rapidly, what happens? The material on the outer edges thins out, right? But the heaviest, most dense material is forced to gather right in the center. Well, that is exactly what happened to the solar nebula. As the nebula spun faster and faster under all that immense pressure, it flattened into a disk. The outer parts thinned out, but all the incredibly dense gas and dust was packed super tightly into the very center, which eventually formed my core. And just like that, I became what scientists call a protostar. Now that we've covered a bit of my history, let's open up the textbook and look at my anatomy. You see, I am not just some simple ball of fire. I am a highly structured, 6-layered machine. Deep inside is my core, the ultimate power reactor. Surrounding that is the radiative zone, which is a remarkably dense path. Then comes the convective zone, a bubbling fluid path. After that is the photosphere. That's the visible surface you actually see from Earth. Just above that sits the chromosphere, a glowing red layer you can really only see during eclipses. And finally, there's my corona. That's the incredibly hot, extended outer crown that stretches millions of kilometers into space. Now, what's really interesting about this is what happens right outside my core, in the radiative zone. Imagine a single particle of light, a photon, trying to escape my core to bring you some sunshine. The radiative zone is so incredibly dense with absorbing and re-emitting photons that this poor little particle bumps into matter, gets absorbed, and is re-emitted over and over and over again. It's exactly like a person trying to slowly push their way out of a massively crowded, tightly packed room. Because of this endless bumping around, it literally takes a single photon millions of years just to navigate through this one single layer. No way, right? But it's true. Once that persistent light finally pushes through the crowded radiative zone, it enters the convective zone. This is where things get a bit more fluid. I actually like to think of this layer as the school cafeteria kitchen. It transfers energy by functioning exactly like a pot of boiling water on your stove. Searing hot plasma bubbles up toward the surface, releases its energy, cools down, and then sinks right back down to get heated all over again. These continuous convection currents are what finally carry my energy up to my visible surface so it can shine down on you. But you might be wondering, where does all this energy actually come from in the first place? Well, let's travel back down to my very center, the core. It is a place of terrifying, awe-inspiring power. To put it plainly, my core operates as a continuous, perfectly controlled hydrogen bomb. It is a massive nuclear reactor where the pressure is so agonizingly intense that atoms are literally smashed together. So we're not just talking about fire here, this is nuclear fusion. It's the most powerful force in the universe, happening continuously, yet perfectly contained right in my heart. Let's look at the actual chemistry of my classroom. 90% of the light shining on your face right now is the direct result of burning hydrogen. In phase 1 of this reaction, that extreme core heat and pressure forces hydrogen atoms to violently fuse together to create helium. Now, helium is incredibly important here. It acts as the base catalyst, continuing the fusion process under extreme heat to eventually fuse into carbon in phase 2. So I am basically just a giant cosmic chemistry lab. So the crucial point here is the staggering number, 15 million. In order to smash hydrogen into helium, my core has to reach an unimaginable temperature of over 15 million degrees Celsius. To put that into perspective, my outer surface, the photosphere that you actually look at, is a mere 6,000 Kelvin. So it's actually relatively chilly on the outside compared to the 15 million degrees raging in my core. That immense heat is literally the only way to sustain this massive chemical reaction. But as we all know, even the greatest teachers must eventually retire. I still have 6.6 billion years left on my contract, but the sad truth is, my fuel is finite. One day, all my hydrogen and helium fuel will completely run out, and when that happens, all chemical reactions and activity in my core will abruptly cease. Without that outward pressure from the fusion, gravity is going to win, causing my outer surfaces to explode outward into space. My glowing core will be exposed, transforming me into a massive red giant. And finally, long after the explosion, I will slowly cool, shrinking down into a tiny, quiet white dwarf. When my school finally closes forever, it won't be a quiet dismissal. It will be an event of absolute, catastrophic destruction. The very moment my chemical reactions stop, my massive gravitational pull will vanish entirely. All 8 planets, including my absolute favorite, Earth, will instantly lose their orbits. They'll just drift aimlessly into space, leading to massive planetary collisions. Earth will instantly freeze in complete, eternal darkness, absolutely battered by the temperature anomalies of my exploding outer layers. Basically, the solar system as we know it will end. It's a pretty sobering thought, isn't it? Everything in this universe, even a cosmic headmaster like me, has an expiration date. But hey, we still have 6.6 billion years of class left. So I want to leave you with this final thought to ponder next time you look up at the sky. Knowing that my light is finite, knowing the incredible journey it takes from my 15 million degree core pushing through a crowded radiative zone just to reach your skin, how will you use the energy I give you in the classroom today, before the final bell rings? Class dismissed. Have a bright day.